video, pair testing. Okay, this is a demonstration of pair testing, and I'm going to use the Aqa S3 January 13 question 2. I picked a simple one in which we've just got a sign test to do at the end of it to keep it simple, so we can just focus on the pair testing aspect. Okay, let's have a look and see what the question asks us. A country requires all students in year 7 to take a cognitive assessment test, CAT. An educational psychologist is interested in the difference in performance in the test between students who have autumn birthdays and those who have summer birthdays. 9 pairs of siblings where one sibling was autumn birthday and the other has summer birthday are selected. The scores achieved by each of the 18 students in their Year 7 CATs is given in the table below. So it says, assume that the pairs of siblings form a random sample. So that allows us to compare the distributions. And so this we've got here, that's our data, our test data. Okay, so that's our basic set of information. Now let's whiz our way down. There's 2 things they're going to ask us here. Explain the purpose of using sibling pairs. That brings us back to your fundamental of pair testing. So we've got two reasons we're doing pair testing, because we're trying to eliminate other factors. In this case, the human factors, so that might be genetics, might be social background, etc. But it's other factors. Those are not the factors that we're looking for, so that we are more likely to see the effect of the factor we're looking for, we're testing for, which is, and that was which is the birth season. Yeah, those are your 2 points you're looking for there. Okay, so we're now going to go on. Let's just hop down a bit and see what it says about next part. It says carry out a sign test at 10% significance level to investigate whether, on average, the students with autumn birthdays gain higher, so we've got word higher there, CAT scores than those with summer birthdays. Okay, so that's good as our start position. So on this, we can set out our hypothesis. Now, H0 in sign testing always relates to the medians, because we're making an assumption that the 2 distributions here, the autumn and summer, have the same medians. Yep, that allows us to use our binomial that for whatever size of sample, there's a 50-50 chance of them being higher or lower, so we're going to put a probability of 0.5 because the median's in the middle. So in this case, we're saying that the SAT, so the CAT scores for the autumn equal the CAT scores for the summer. Then we've got to look at our alternative hypothesis, H1. Now, here we've got to look for what the question's asking us, because we could have a form that says not equal to, which is a 2-tailed test, or we can have something that's greater than or less than, in which case we're going to have a 1-tailed test. In this case, they are telling us in the question that the test is whether the CAT scores for the autumn born are greater than the CAT scores for the summer born. So that's giving us a 1-tailed test. Yeah, we're okay with that. Good. The next thing we need to do add some space here, is to calculate our test statistic. And in this one, we're looking at signs. But what we've got to do is calculate the sign of the difference between the pairs. So we've got to derive the difference. So let's hop up back to the data. Go back to the data and start looking at that. So let's do, as we're trying to see whether the autumn is higher than the summer, autumn minus summer score. So that's going to be our score. Yep. So 82 minus 81. So that's a positive score. It's an increase. Yep. A higher score. 76 minus 61. So that's a plus as well. 62 minus 49 is also positive. So all three so far, the scores are higher for the autumn born. 58 minus 49 is higher. 74 minus 68 is higher. 65 minus 51 is higher. 60 minus 65 is lower. 50 minus 63 is lower. 81 minus 72 is higher. So those are our sign scores. Now we've got to sum them up. So let's have a look at how many positives we have on here out of our how many pairs? 9 pairs. 1, 2, 3, 4, 5, 6, 7 positives and 1, 2 negatives. So we've got 2 negatives. So we know that should add up to 9 because we had 9 in our sample. Good. So we've checked our calculations. So let's work down now and use those figures. You've got a positive of 7 and a negative of 2. Okay. So how can we use this? Well, we know that we've got a binomial. We had a population sample of 9 and we've got a 0.5, and we want to find the extreme ends of our probabilities, the binomial probabilities. So we've got 2 extremes. One is the probabilities that x is greater than 7. That would be more extreme than 7. And the other one is that the probability of the x is less than 2. Now we know in our calculators that we can use B, C, D to find a less than or equal to. So let's use the bottom one here, the lower, and that's what you usually end up doing. So let's open up our calculator now, get it on the screen, carry out that calculation. Here we go. Menu, stats, distribution, binomial, BCD. Here we are going to use a variable. So our first one, x here, is the outcome we're looking for, 2. Number of trials was 9. Probability 0.5. Therefore, executing that, we get a figure of 0. The probability of this is 0. I'm going to round that because I don't want to have about 6 decimal places, so it's going to be 0.09. 0.09. So that's going to be our test statistic. Our test statistic is 0.09. There we go. Now let's have a look at our critical value. Critical value. So in a sign test, it's just going to be the significance level. Significance level. And in this case, let's just go back and check what our significance level they asked us to test against was. It was 10%. It's 10%. And here we're looking at a one-tail test because we will get greater than. So all that 10% is at one end of our hi-ho line. If it was a two-tail test, we'd have to split it. So let's draw now our hi-ho line and get that sorted out. So we'd have a line like that. And the most extreme position is a very, very low probability, isn't it? We're looking for something that's got a really low probability of occurrence. And the lowest probability is 0. Then we're going to add our critical value, and in this case our critical value was 10%, which is 0.1. There we are. So now we know our more extreme area, our critical region, where the H1 is going to be the conclusion, is less than 0.10, and our HO area is going to be more towards the middle. Then we're going to put our test statistic on in the right place, and in this case it's going to be a 0.09 test statistic. So that's in our critical region. So what we've got to do is write to get the mark scheme is that the test statistic is less than the critical value and that H0 is rejected. So now we've reached a conclusion. We've only got one thing left to do on a case like this, and that is to complete our context statement. Now, when we've got a case where we rejecting H0, we're starting always with there is significant evidence. That. And now we're going to go back and we're going to lift and shift the information on the test that they asked us to carry out, whether on average students with autumn birthdays gain higher CAT scores than those in the summer birthdays. On average, students with autumn birthdays gain higher CAT scores than those with summer birthdays. There we go. So what do you get for that? Looking back at the score sheet and the mark scheme, for completing the calculation, you're going to get 6 marks. Congratulations, that's 6 marks for completing that calculation. So finally, here's a little summary of the pair test and the sign test. With a sign test, the top 3 items are specifically on the pair test, and the key point being that you've got 2 sets of the same data that are paired, so they've got a number above them, 1, 2, 3, 4, etc., and you have to calculate the difference. Then you use the difference to do the sign test, but you could at that point use the difference to do the Wilcoxon signed rank test as an alternate. So there you are. I hope you found that useful. Thank you for watching.